So before I start this presentation, I just want to make a few comments. This is a dual presentation, not just an interview, a dual presentation with Rob Lowe. And Rob's background is in engineering, another side of engineering to myself, but engineering, and so he can do the maths like anyone else can. And it's a very interesting interview. But the main thing about this interview, the main thing about the whole video is just one thing. What is the difference? What is the fundamental difference between the climate alarmists, and climate realists like myself and Rob? Well, the difference is very, very simple. And it is actually just what we call the feedback on how CO2 behaves. Let's say CO2, regardless, does some warming. Then that increases the warmth of the atmosphere, which increases the moisture content, the water vapour. And that water vapour is a greenhouse gas, so that causes more warming, which causes more warming, which causes more warming. It's called feedback. That is the difference, because people like myself, the realists, say, well, that doesn't happen. It isn't there. The data doesn't show it, as you'll see. And it doesn't happen in nature that way. And that is actually what the video is about. But in going through this, I promise you will learn things. And I've made the video very easy to follow. So I've stopped the conversation at times and explained to amplify a point and make it simple so you've got the message. So with all that said, thank you for watching. I hope you watch it all. I really would appreciate that. Please like the video now and share it. Please do those things, because that's the benefit, is to get the message out. All I'm about is the message. So here we go. Welcome to the new video. Well, hello everyone. Today I've got a man called Robert Lowe, who I've been communicating with for a little while now, and recently did a Tom Nelson broadcast on the Tom Nelson podcast, and gave an excellent talk on the climate change issue, if you like. But there were some points in that talk, and by the way, the link to that is below this video. So if you want to watch the full thing, it's below this video. That gets more technical. But today we're going to remove, if we can, a lot of the technicalities. And the main subject is going to be what is really the difference between the people like Rob and myself on the what I call the climate realist side, and the alarmist side. What is scientifically the difference? Because it isn't good enough to just fight net zero and the madness of net zero. You've really got to understand that it's unscientific, the basis of it, the root of it all. The CO2 myth is unscientific. And so this video is about explaining in everyday terms, if we can, we're going to try and do that, why, or what that difference is. So why are people in one side saying the temperature's going to run away, it's going to be terrible, it's going to scorch the earth, and we're going to set fire to everything? And why on the other side are people like Rob and I saying, no, that's not true? So without further ado, hello, Rob.
Hi, good morning, Paul.
Good morning. So we'll start off. Let's start off with what do you think is the basic difference between the two sides? Because, well, let's start off with saying, what do the two sides agree on? This may surprise people. What do the two sides of this agree on?
I think we all agree that carbon dioxide is a greenhouse gas.
Yes.
And were it not for its presence, the planet would be too cold to live on.
Yes.
We could not exist without it. But where we very quickly disagree is that carbon dioxide has done its job. It's done the heavy lifting. In other words, it keeps us warm. It is a greenhouse gas, but it's what scientists refer to as being saturated. That means that if we add any more carbon dioxide now to the levels that we currently have, we get practically no difference in the temperature. You cannot use carbon dioxide as a control mechanism to control the planet's temperature. It's a bit like painting a wall of your house. If you wanted to change the color from white to, say, blue, You put on one coat of paint and you can still see the white shining through. You put on two coats of paint and you can hardly see it. And by the time you get to three coats, you can see no more. And exactly the same analogy applies to carbon dioxide in the atmosphere.
Can we sort of quantify that? So let's assume if that's the case, then the first little bit of carbon dioxide made a huge difference. Compared to, let's say, a molecule of carbon dioxide back then at the beginning, if we had this in theory, and a molecule now, what would the ratios be, sort of?
That's a very good question, Paul. If you go back, let's take a thought experiment. We've got an atmosphere with zero carbon dioxide in it, and we add 1 part per million, the very first part per million, and we measure the effect, the radiation effect of adding that amount, how much heat is retained by that molecule, that first part per million, and we compare it to adding 1 part per million today, where we are somewhere between 425 and 430 parts per million. So that's call it 1 in 400 or 1 in 0. The first molecule would have 1,000 to 10,000 times bigger effect than an additional molecule does today. And that illustrates this concept of saturation. The effect now is hugely reduced from what it was when, if we had a planet with extremely low carbon dioxide concentrations.
Well, it's always difficult to remember details that aren't particularly important, and this isn't, but it's interesting. The logarithmic relationship was first described by the Swedish scientist Savant Arrhenius in 1896. And guess who's a direct descendant of him? Yes, this young lady here, Greta Thunberg. Small world, isn't it? Yeah, but as I understand it, the alarmist model, well, they say they've accounted for this. They've counted for what, in scientific terms, we call the log scale. I think it's log to the power of 2, but the log scale
Yes.
of the nature of CO2. So what would be the effect now? And one of the things, just to tell everyone, people use in science is, what would be the effect of doubling it today? So to keep the numbers simple, let's take it. It was 400 today, and it went to 800. That's doubling. I've got two questions, Rob. One is, how long would that take? And even though it's still got some effect left, what would that produce in terms of temperature rise? And do the two sides agree or disagree on this?
Well, I think the two sides have to agree that it would take until the year 2200 for the quantity of CO2 to double in the air. If we take the current rate of addition, which is something between 2 and 2.5 parts per million per annum,
Right.
it would take until the year 2200 to double. If it doubled, the temperature rise would be less than 1 degree centigrade.
Right, but in fact, it's about 0.7, isn't it?
About 0.7, yes.
William Happer puts it at 0.7. So on both sides, more or less, I think so. They may say 0.8. It doesn't really matter. Both sides pretty well agree on that, don't they?
Yes, the IPCC, I think, has a figure of 0.8, but whether it's 0.73 or 0.8, you're talking about very small differences.
That's right. So both sides broadly agree on the logarithmic scale on this diminishing effect of CO2. So I'm trying to get agreement here between the two sides to explain to everyone just where we are and where the divide will come. So both sides, I would say, then agree on the diminishing effect of CO2. They agree on the numbers. Yeah.
Yes.
Okay. So, I mean, that wouldn't be a problem because I'd like to say now that to have warmed 2 points, 1850 was the start of the Industrial Revolution, and the warming actually started about 150 years before that, by the way. So the Earth was warming 150 years before that because the Little Ice Age minimum was in the 1690s sort of thing area. And then of course there was a very small amount put in the air then, but we started putting the CO2 in the air in the Industrial Revolution. But it was very cold then. So if you go back to 1840s when the Thames rose over last and so on, when you have that, we don't want to go back to that because I know in terms of water resources, their biggest droughts were in the 1700s. The biggest drought on UK record by a mile, the reference drought in the 1700s, and all the worst droughts were the 1700s, the 1800s. Worldwide famines then were absolutely terrible. The weather was more extreme then, and we don't want to go back to that.
Yeah,
So what always amuses me is why they go on about the 1.5 degrees, which has been overall hugely beneficial to mankind.
absolutely. And if you look, even the NASA photographs show the greening of the Earth.
Correct.
There's been of the order of 20% greening in 30 years. And that
Yes.
anybody can go and look up on the NASA
Mhm.
website.
But even if you then say, well, it's not just the CO2, because everyone knows CO2 is plant food, but it's not just that. It's the nitrogen fertilizer coming from fossil fuels, by the way, as well. Those
Absolutely.
the effect of both of these things rely on in effect the burning of fossil fuels.
And
Um,
a slightly warmer climate also helps
that's right, absolutely it does, and
help
that's
with
why
crop
we
production.
it's why we put the CO2 back in to the atmosphere. And most plants actually evolved in higher CO2 levels that were, sort of 3, 4 times, 5 times, or 3 to 4 times what they are today. We
Yes.
can't afford to put that level into greenhouses because it's too expensive, but they try to do it at 1,000 to 1,200. So they try to do it about 2 to 3 times what it is today. And
Yes.
they're called C3 plants. That's the bulk of the plants. There are some plants, C4s, that
Yes.
have sort of started to accommodate to the lower CO2 levels, but they're not the main plants that feed us.
No,
So
they're not, but they are. It's again, it illustrates how evolution works. They're the smart plants because they can work with low concentrations of CO2
yes,
better than the C3 plants can.
yes, it's the way they trap it in, yeah, and so on.
Then
So,
there's another route. There's the CAM route, CAM route, and that's what the cacti use.
yeah,
They collect their CO2 at night.
right. Okay, that's good. I didn't know that. And
Yeah.
we've highlighted what both sides agree on, which is the temperature increase if we double CO2, if we have to wait another 175 years for that to happen, and we double CO2, we're going to get somewhere in the region of zero point 0.7. But it's not as simple as that, is it? Because what they then say is they say, oh no, that zero point 0.7 warms the planet and puts more water vapor in the atmosphere, and water vapor is the biggest greenhouse gas of all, and that's going to cause warming, and we're going to get a runaway, what they call positive feedback. So one thing warms it, the warming creates more warming, that warming creates more warming, and we're away. That that is what they're saying, and your side doesn't say that, or our side doesn't say that, does it, Rob?
No, not at all. And uh, feedbacks have been around ever since the planet was created or formed. They don't suddenly switch on and switch off. The other thing to remember is that all we need is a 1%, literally 1% change in cloud cover, and you'll get exactly the same effect as doubling the CO2 concentration. It will have the same temperature effect as doubling the CO2 concentration. And if ever you look outside and look at the sky above you with clouds passing by, it's changing by a lot more than 1% from hour to hour, even from minute to minute. So the the clouds have a much bigger effect on temperature than carbon dioxide does.
Cloud cover is also linked to the strength of the sun's rays. When the sun's rays are weak in its cycles, it lets in more cosmic rays from space, and that allows more nuclei to form and raindrops to form and clouds to form. And there's a lot of work being done on this, and my own work in the 1970s with building models of this showed that relationship between the sun's rays and cloud cover. So,
But the
okay.
other point that is the people wrongly say that you get a positive feedback, but nature does abhors a positive feedback because positive feedbacks don't switch off. It's like an explosion. And remember, positive feedback can work in two directions. If you got any cooling of the planet, then you would go into a rapid decline of temperature, which is just as likely to happen as a rapid increase in temperature. And given that carbon dioxide is pretty much saturated already, the tiny difference that it is making to temperature cannot lead to a big positive feedback. My own personal view is it's going to be slightly less than the 0.7. There'll be a negative feedback. The Mother Nature will try and return the Earth to a temperature of about 15.5 degrees centigrade, which is where it is today. But it might not succeed, but that's what it'll try and do.
Yeah, so what we're saying is, if anything, feedbacks tend to be negative. In your talk with Tom Nelson, what struck me was the little example of the barbecue.
Yes.
Basically, if you had a barbecue, you're now heating the air. Now let's take a barbecue creating positive feedback. Can you expand on that?
Yeah, well, what would happen is if you lit a barbecue, you'd be putting heat into the Earth. Now, the positive feedback doesn't occur because of carbon dioxide. The positive feedback occurs because of temperature. And when you light a barbecue, you are heating the air around you. That should therefore lead to more water vapor because you're warming the air. The air can then absorb more water vapor. The theory then goes that air will absorb more heat and therefore it'll get warmer. But you can see the cycle that you get in because it cannot stop because as the temperature rises, according to the theory of water vapor heating the planet, it means that every step will lead to the next step, which will lead to the next step, which will lead to the next step. You can put your barbecue out and the process won't stop. There is no mechanism for it to stop. So clearly that doesn't happen.
So what you're really saying is a barbecue could cause the end of the earth as we know it.
Yes, it could do. Yeah,
That's right, with positive feedback. Yeah, but
yeah,
nature doesn't like positive feedback, does it?
not at all. I can't, the closest you get to in nature with positive feedback is childbirth, where the pregnant mother gets the signal for her contraction signals, feedback to the brain to squeeze harder and squeeze harder until the baby is born, and then it all stops. But
Yeah.
that's an example of a
And
positive
of course, they
feedback.
used to worry about out of control feedback going when they invented the atomic bomb. And they
Yes,
used to worry about it'll spread, it could actually explode the entire Earth. And that's a positive feedback for a while to cause the bomb.
yes,
So TNT is a positive feedback for a while, but it doesn't carry on. Yeah,
it doesn't.
but that's not natural. We force those things. So yeah, so the difference then would it be as simple as saying that the difference between the two sides is just this positive feedback? Because without the positive feedback, the other side hasn't got the alarmism.
You're absolutely right, Paul. And the IPCC ran into trouble when they realized that the carbon dioxide, the heating effect is saturated. And they then had to come up with an alternative explanation because this has only been the positive feedback story, as far as I know, has only been a topic of discussion this century.
Mhm.
Before that, everybody thought it was running away because, of some questionable predictions of the future.
You're right. Anyway, it didn't really become a subject of discussion until in this century.
Yeah, yeah. And it's a great shame that this has happened because every time something changes, somebody has to go and look for another reason why it might be happening. It's not the way you do science. And then, Paul, if you look at the hundreds of models that have been developed, not one of them, not one, without exception, has been able to forecast the past 25 years or 50, no, sorry, since about 1980, we've been able to measure global temperatures accurately, and all of the models are wrong, every one of them.
Yes. Robert's just made a very critical point there, so I'll just pause. And here's a quote from Richard Feynman, one of the great scientists of the previous century. In general, we look for a new law by following a process. First we guess it, and then we compute the consequences of that guess to see what would be implied if this law that we guessed is right. Then we compare the result of the computation to nature. With experiment or experience, compare it directly with observation to see if it works. If it disagrees with experiment, it is wrong. In that simple statement is the key to science. It does not make any difference how beautiful your guess is. It does not make any difference how smart you are. It makes no difference who made the guess or what his name is. If it disagrees with the experiment, it is wrong. So let's just see how what Rob referred to as the climate alarmist models figure out with that totally basic understanding of the scientific process. Now, don't be alarmed. This squiggly graph looks complicated, but it's not. And I just don't want you to stop watching the video because I'm going to make it simple to understand. What we got is all the squiggly lines. What are they? They're the climate models, the alarmist models. And they actually show the increase in temperature over time. The graph starts in 1983, showing the increase according to them over time. And we got a blue and green lines here. They're the observations of two things. One is the surface temperature, that's where we live at the surface, and the other one is the atmosphere we live in. It's called the troposphere, but it's the atmosphere we live in. And you can see there's quite a big discrepancy. So against observation, they're all wrong. And that's the point Rob is making. And in fact, if you think about this, there's around about 90 odd or something predictions there. And the predictions are just opinions. They're not evidence. And because they don't check against observation, we know they're wrong. So the average black line of all the predictions is not the average, actually the average predicted temperature by the models. It's the average of the wrong predictions by the models. And that's the point Rob is making. Now to clarify this further, just look at this chart here. This is based on the American states, actually, and it's work by Roy Spencer, recent work. And there are all the predictions according to a lot of models. And that the blue bit there, just there, that is the actual measured temperature. So we know the models are wrong. And they all can't be right anyway. Think about it. They disagree with themselves enormously. They're just guesses, no more. They're not observation. And that principle is what Rob is trying to drive home. They're all wrong. So actually, I think what I find amazing, and people are listening to this, most of them are not scientists, they're just ordinary people, want to understand, you're trying to solve it for themselves. I mean, even with extreme weather, the IPCC themselves, with Table 1212, say, you know, there should no human detection in forest fires, in rising sea levels, in droughts, in floods, etc., in hurricanes, and all that. Now, you can go into detail about all those things, but the scientists are not saying that is the case, actually, on the other side.
No.
And so it's the politicians get in the way because what the politicians go on is a political document written by politicians called the IPCC Summary for Policymakers.
Yes.
And that's written by a political representative from each country, not by the scientists.
Yes.
And so everything gets distorted back to an agenda, and that isn't science. So would you agree with that statement?
Oh, absolutely. Yeah. No, I totally agree. The difficulty is the general public couldn't possibly read the IPCC scientific report, which runs into something like 900 pages. I don't know how anybody can read it, to be frank.
Yeah.
But what the summary says and where it started, you wouldn't recognize it as the same document.
No, that's right, because it's a political document, in my view, about the transfer of wealth to the third world. It's a sort of leveling out of globalism document rather than a document based on science. And I would argue this. I have had clashes on television. I've had clashes with professors and so on, and everyone runs away from debating this. And what they'd rather do is call me names. So it's personal attacks. And the one things I never do, and I always start my talk explaining this, is I never ever try to put an argument by attacking the person. And that's I just don't do that. And I don't appeal to authority either. So I don't say I'm right because he says I'm right, no matter who he is. I actually start my talk showing a clip of John Clauser, the Nobel Prize winner in physics.
Yes.
And I say, you know, he says it's all a pile of crock or something he uses, the CO2 myth. And I say, that doesn't mean anything because if I use that, that's an appeal to authority.
Exactly.
It means nothing. So without skepticism, you don't have science. And today in schools, children are being taught what to think, not how to think.
Yes.
And that goes to right through to the universities, I'm afraid.
Oh, absolutely. Um, the main reason behind me producing that or having that podcast with Tom Nelson on the greenhouse effect was to try and simplify the science without going too far, because you can lose the science if you're not careful.
Yes.
I hope I've achieved that. And I'd leave it up to the viewers to decide whether or not they can make sense of it. But to try and get the message across that we're not a bunch of funny guys, we actually understand the science. And if you really do, you realize that it isn't true science that says that the planet is warming because of CO2.
That's right. And the warming's been beneficial. I mean, we actually have a swing in temperatures in the day that's massive between day and night. And we also head off to hot places for our warm places for our holidays. Right. And if you don't believe that clouds make this difference, just think what happens. Imagine you're sunbathing in your bathing costume
Yes.
on a beach. And imagine a nice cumulus cloud, nice white cloud comes over. You go into shadow immediately, and you feel the cold immediately. And for those who say, "Oh, but it insulates as well," it does. But the actual reflection back is far more powerful than to the insulation effect. And that is just a scientific fact. Some clouds, very, very high clouds, actually can actually warm the planet. But your normal clouds, they're doing the cumulus
Yeah.
clouds and so on. They don't. All the low-level clouds don't. They cool the planet overall.
Yeah.
Okay, Rob. Well, where do we go from here? Is there anything else you'd like to say on this to get the message across? What messages to the layperson do you want to get across? Because what we've discussed so far is both sides accept the basic science, but both sides disagree about the feedback,
Yeah.
yes, and the effect of it.
Yeah.
And and I, as we also agree that we don't have science these days. I don't call them climate scientists because unless they're willing to accept and debate the skepticism, that's not science. So the scientific process is gone. But I don't know whether you'd like to add anything now.
I don't understand the term climate science. Um, you would have to be a mathematician, a statistician, a chemist, a physicist, a biochemist, a geologist, and a whole host more to
Yes.
be a climate. It would take your whole life,
Well,
and they
let
over
me,
they over egg the academic aspects of it. It's basic physics. That's what determines what's happening. There's nothing. That's the overriding feature. Forget all the other things about climate. The physics says that carbon dioxide is saturated, and therefore it cannot warm the planet by any significant degree anymore. It's done its job. It's there are other reasons that the temperature is rising. And because we're not doing the research to really find out what they are, we don't know what they are. We can surmise, but we don't really know the real reason.
right. Well, we both have a hero in this. We both have a hero in the physics, a chap called William Happer,
Yes.
and he is a very mild-mannered man. I communicate with him as well, and he's a very mild-mannered genius to me.
He is a genius.
and I've done many a video on him, and I actually have made of his model. By the way, I created a cartoon character to try to explain to people that what he's doing. I sent it to him. He loved it. The fact
Yeah.
that this little cartoon, a CO2
Yeah.
molecule doing all dances in different ways. Anyway, not is there anything else again? I mean, William Happer's work, by the way, he is probably the best at the science in this, and all they do is personally attack him, really,
They
right?
do. I'm going to make you a little bit jealous, Paul. I've twice been to see Happer in his office at Princeton University.
I'm jealous. I am jealous.
I have a son who lives in New York,
Yeah,
and I visit them a couple of times a year.
all right.
Almost every time I go, I make it my business to go and see World. He
Right.
is the most modest man you'll ever come across.
Correct.
He is his knowledge, his breadth of knowledge is breathtaking. His depth of knowledge is breathtaking. And why he's not a Nobel laureate, I don't know, but I suspect it's because his really good research was done for the Department of Defense in the US, and
That's right.
it was confidential, the work he did.
Yeah.
He's the guy that's got the modern telescope to work. Little do people realize that. Um, it's because he built that
Yeah, the compensating
optical
laser. Yeah,
correction
that's right.
equipment, yeah,
Yeah.
so that
No,
you get rid of the flicker of a star.
that's right. He accidentally, out of research work, to get a laser a gun, as it were, that came out of it
Yeah,
because the clouds got in the way. The clouds what mucked up that research, wasn't it?
yeah,
But out of that came something that really has helped all astronomy. Yeah, it's now standard kit, as it were, and
yes,
lots of other things. I
mm,
mean, here's a marvelous man, and I'm jealous that you meet him. Okay.
yeah.
Well, thank you very much, Bob. Nothing else? You know anything? Ending
But
message?
one little thing, if people would like to get to know Will Happer a bit better, Joe Rogan did an interview with him 2 days ago. It's a 2 hour interview, and it's very well worth the watch. Uh,
Right.
he
Link,
covers this whole
link,
subject.
link will be below this video. Okay, I know
Yes.
about it. Yeah.
Okay. Yeah, it's a very good one to watch. But
Good.
otherwise, all I can say is um, hmm, please be rational. Please try and understand what's going on. Think for yourselves, work it out. We really don't need to spend all of this money on net zero. I haven't even covered how little benefit that will be anyway. The temperature that rise that you would avert in the UK is 0.001 degrees centigrade by 2050. You can't measure that. It's crazy. It's so little.
That's a thousandth of a degree, by the way.
Yes, a thousandth of a degree. Yeah,
Yes. I mean, it's irrational, and it's amazing that our politicians
yeah,
are so irrational.
yeah,
And they may be lawyers or have, I think they're called PP. They study at Oxford and Cambridge, politics, philosophy, and something else. But what
yeah,
they're lacking in is basic understanding of science.
yeah, yeah. I would
Okay,
totally agree.
thank you very much. Well, I'm sure we'll meet again on another Zoom. I think this has been a very nice interview, and I thank you very much for it. And there we go. Bye bye, everyone, and thank you for watching.